This is the solution video for section 5.3, problem number 2. All right, so it says gas is being pumped into a spherical balloon at a rate of 5 cubic feet per minute. Find the rate at which the radius is changing when the diameter is 18 inches. V equals 4/3 pi r cubed. Remember, this is the volume formula for a sphere, right? So we're giving you that. You don't have to worry about that. Now, I'm also giving you this hint 18 inches is 1.5 feet, right? And so it's important to note that this is given in cubic feet per minute, but this measurement is given in inches. So, of course, the hint is necessary. All right. Um, our first step said to draw a picture, right? Well, here's our picture, right? I guess it's not a huge thing, but we have gas being pumped in, right? So there is a certain volume of air or gas into the tank, right? And that's changing, right? Because you're pumping it in, right? So there is a dV dt, right? A rate of change of the volume, right? Now you're told that it is 5 cubic feet per minute, right? And so that would be 5. Now, specifically, it is positive 5 because the volume is increasing, right? Because you're pumping it in, right? So you want to make sure that you understand that. All right, cubic feet per minute. All right, now what else is going on? Well, there is a particular radius of the balloon, right? And the radius, if the gas is being pumped in, the radius is increasing, right? So there is a dr dt, which is some positive value, right? But it says find the rate at which the radius is changing, right? And so that's what we're trying to find, right? So that comes to our find statement. So find dr dt when what is true? Well, when the diameter, right, is 18 inches, right? So it's important to note diameter, right? Which means the radius would be 9 inches, right? Or remember, 18 inches is 1.5 feet, so 9 inches would be 0.75 feet or 3/4 of a foot, right? So that is very important. That's actually the value that we're going to use, right? So now I have our volume formula, 4/3 pi r cubed. And so what we want to do is we want to take the derivative. Derivative of v is dv dt equals, now 4/3 pi, remember that's just a constant, times the derivative of r cubed. Derivative of r cubed is just 3r squared, but then times dr dt. So now the find statement, find dr dt. All right, so that's obviously what we want to know. So in order to find dr dt, I'm going to have to know r, which I do, and I'm going to have to know dv dt, which I do, right? I was given that. So I plug in 5 for dv dt. I have 4/3 pi, pi times 3, so the 3's can reduce. So I just have 4 pi times r, which is 3/4 squared times dr dt. And so now I want to solve for dr dt. All right. So I can simplify a little bit before I do that. I've got 4 pi times 3 fourths squared, right? So that would be 9/16. Of course, the 4 and the 9, or so the 4 and the 16 reduce. And so I'm left with 9/4 pi times dr dt. All right. And so now I want to multiply by 4, right? And so I'm going to get 20 equals 9 pi times dr dt, and then I'm going to divide by 9 pi. So dr dt is equal to 20 divided by 9 pi. Now notice the 9 pi is all in the denominator. It's not 29ths pi, or it's not 20 pi's over 9. All right. It is just this. Now, what are the units? The radius is a linear measurement, so that would be in feet per whatever the unit of time is. And so the unit of time is minutes. So 20 over 9 pi feet per